Hi, this is one of the learning goals of this course. As an academic professional, you will have to be able to read and learn new knowledge, to stay updated or to get acquainted with new fields of expertise. Therefore, you must read books and articles and use Wikipedia wisely and no longer rely on student textbooks. You also have to be able to read and understand empirical articles. Articles that present a scientific method to generate new knowledge from reality. When you can do that, you can judge yourself how true and useful the knowledge is for your own professional practice. When you understand the empirical article, you should be able to describe the methods of the study. Understanding is about what they did in the study, the method that was used, but also knowing how valid the results from the study are. You will be offered several empirical articles in this course. Empirical articles mostly exist of an introduction that explains the background of the study, the problem. In psychology, there is always a psychological theory outlined, mostly with expectations or the hypothesis formulated. The method concerns the core of the scientific study. The method makes it scientific. The results part presents the findings with numbers, statistics or qualitative findings. The discussion part gives meaning to the results, places it in a broader context of the existing literature and reflects on the limitations of the study. I recommend you to read the articles completely. To check whether you understand it, try to explain it to somebody else. How true the results are depends on many aspects of the study. For example, when a theory or research question is about a causal relation, one factor causing an effect in another factor, in general, an experimental design is the most saying. It provides the strongest evidence about causality. At the least, the cause should be assessed before the effect, as in a longitudinal design with T1 and later T2 measurements. When cause and effect are assessed at the same moment cross-sectionally, then conclusions on causality become really tricky. Besides the design, the sample is important. Who are the participants? Are they university students? Only older women? Or a sample of managers in a banking company? How diverse is the sample? Is the sample representative? Representative of whom? Also, the number of participants is important. In general, with few participants, only large effects can be demonstrated. More subtle or smaller effects need larger samples. The measurements also are very important. They should be valid. Assess what the study really meant to assess. In addition, they should be reliable, giving the same score each time the same state is assessed. Most of these rules are about quantitative research. Research that codes findings in reality in numbers that are put in a data file. Quantitative research is limited to things that can be coded into numbers. But when this is possible, this research can compute the patterns that are in the data and often not visible without statistics. But how do we start? How do we get ideas about what we should measure? Often this is with qualitative research. This type of research gives complex and meaningful views on what we study. It is a kind of hypothesis exploration and generation based on the rich data from a few units provided by qualitative research methods, such as depth interviews, observations, and analysis of meaning. While in quantitative research we might study the relation between a specific attitude and actually voting behavior in a sample of 150 employees, in qualitative research we might develop semi-structured interviews with 10 employees and ask why they have this attitude, what their experiences are, how it feels to vote, and what they thought during voting, and many other aspects. The methods used in qualitative research are highly linguistic, tailored to unique cases, iterative between theory and interpretation, and empathic. Here's some more background information on quantitative scientific research to get you into the mood. This is a crude summary of the field of quantitative statistics. The things we do with quantitative data to give them meaning. Firstly, there's a limited number of aspects of the data that are used. Individuals and samples have means on variables, average scores, or proportions, such as percentages. Secondly, there's variance. People and groups vary, they differ. Thirdly, there's the number of participants that's relevant. These features of the data are used to compute a so-called test statistic, a number that represents what is going on in the data. What statistic is used to test what depends on the type of the data. Are we analyzing different groups, like religions, or bodily weight in kilograms, or attitude on a scale from 1 to 7? The test statistic can be used to compute the p-value. The p-value is mostly used to conclude whether the hypothesis was true or not. In social sciences, a p-value of smaller than 0.05 is said to present a significant result. Statistically, the p-value is the probability on these data, or even more extreme data, given that the null hypothesis is true. The p-value is under fire, and other aspects of the results may be evenly important, such as the effect size, confidence intervals, our theoretical understanding, and prior findings. All these things are needed to conclude what the results really mean. But for now, concentrate on the empirical articles. Read the articles and explain each method to somebody else. And when you do not know a methodological or statistical term, look it up. You will train yourself to learn and to get smart. Success. Bye.